Hi everyone, thank you for signing up for this TÜV SÜD webinar on Industrial Additive Manufacturing. Are you ready? Our speaker is Gregor Reischle. He is Head of Additive Manufacturing here in TÜV SÜD and is responsible for the AM global activities. With over 10 years of experience in the field of AM, Gregor co-developed and managed 4 EOS dental process chains and wrote 4 patents within this field. So with that, I'll now hand over the presentation over to Gregor, who'll take it off from here. Gregor, over to you.
So let's start the journey to industrial additive manufacturing. I am starting with this slide. So it's an introduction slide. It actually remembers me personally at the beginning of industrial manufacturing. It's a dental process. It's shown a metal printing platform and a person which is into the printer's process chamber removing the powder of a platform. Here we see actually the beginning of metal 3D printing industrialization. The process is highly manual. As you see, the worker is in the chamber. It doesn't have the arm coverage, and we see the platform is slightly oxidized on the sides. So these are the beginnings, the roots of industrialization with our industry. Our mission and vision is in the industry to establish a clear standardized processes to enable the industry and solution providers and implementers to implement their business models and their applications on industrial grade level. Therefore, we formed a team of 20 experts, which are globally positioned in Japan, Singapore, Germany, and US to enable a global industrialization with TÜV SÜD. Our mantra, our message is industrial AM readiness. I am ready. So the question is, are you ready as a solution provider or implementer? And this helps us to communicate and differentiate, because the industrial AM mindset is different from the mindset which is used for prototyping or early stage 3D printing. Therefore, we created 8 themes of competence, which is personal trainings, product approval, which is dedicated to usually regulated industries, process chain certification, as our additive processes are quite complex and long. We talk about next generation additive manufacturing, where digitalization of the industry is a key driver. We talk about hard and software readiness, manufacturing, material and feedstock readiness, of course the facility and companies and management and teams processes, and the standardization. Without standards, we don't have a reference what means actually industrial AM readiness. Therefore, we are very active here on DIN, ISO and ASTM standardization. I chose these 5 topics for today. Let's look what kind of successful use cases for those exist there for industrial additive manufacturing. This is interesting for those which didn't the entrance into the technology, are still considering what might be the right entrance point. Then secondly, we will have a look at the risks of the processes and workflows. Thirdly, we will understand the industrial AM ecosystem, so who are the relevant solution providers and the users, as we believe only if the entire ecosystem works on industrialization, we will make it happen. We will show what we are actually offering for the market to implement the solutions faster, and we will do a quick check assessment for the AM implementers to help them to understand what kind of crucial aspects are needed to implement successfully and fast. Looking at the history, so understanding where actually we're coming from. 3D printing itself was invented in the 70s already. As we're talking since, let's say, 10, 15 years about additive manufacturing already. That means that in 10, 15 years we have the first application detected which are understood as already as a manufacturing use case. These applications are within several sectors: dental, medical, partly consumer related, but as well aerospace and airplane sector. Since, let's say, so last 2-3 years, we see the mobility sector getting seriously into additive. So companies like BMW, Daimler, Volkswagen are detecting first serious applications and implementing those. We are very close to the railway sector, which is implementing here spare parts on demand solutions. So the situation is changing, and if you look today, TÜV SÜD is offering here for those serious implementers clear services which helps them to move dedicated towards small series production. To understand, for those which are already longer in the industry and offering printing services as prototyping or for low-risk parts, that means we usually the topic of reproducibility and traceability was not so strongly required. Changing the mindset toward industrial additive manufacturing, where we print small series and product in regulated industries, the topic of reproducibility and traceability is key. After looking at what's the status of end-use products, we discovered that the number of end components bypassed the functional prototypes in 2018, which means the market size of printing high-end components which require standards, reproducibility, and traceability is bigger than prototyping market, which allows TÜV SÜD to take the decision and say, okay, we invest into this market because it's a significant chance for the industry and for the society to implement new business model and sustainable manufacturing methods which help the growth of additive manufacturing. For the early implementers, we need to discover what's actually the value proposition of your product. At this stage, the technologies is still quite expensive and the cost per parts are significantly higher than classical manufacturing technologies, injection molding and others. So if you don't understand the value proposition, what you're offering to your customers using 3D printing technologies, and don't implement it into your new business model, there's going to be no success today with 3D printing. Let us understand this topic more based on few examples. Looking into medical, the hip replacement here shown in this left picture demonstrates an exact fit to the human body. A new shape is created, complex structures are created here which were not manufacturable with the classical technologies, and on-demand service is possible. These are new value propositions. They haven't been possible with the classical manufacturing methods, and that's why this works. Second picture shows a dental coping. This market is actually one of the most mature ones since over 10 years manufacturing these copings here. Over 1 million parts are produced each year. There are around 500 industrial grade printers in the huge labs producing everyday parts from metal, cobalt chrome or titanium, and they have to have the exact fit. But the key value here is that the cost per part are lower than the classical methods. This is quite unique, usually not possible with 3D printing at this stage as it's still quite expensive technology. But in this application, as it's so small, we have a lower cost per part than a classical method. That's why it's disrupting the classical manufacturing methods already today. That's why we can learn a lot from this application. It's a global implemented on-demand manufacturing solutions, and we can expect within the next 5 to 10 years that the technology costs, the cost per parts, will drop significantly down, and that's why it's going to disrupt other industry sectors as well. As this sector made this journey already in the last 10 years, we know how to implement and how to proceed faster for the following sectors. Looking at aerospace, airplane, turbo machinery sector, here the major driver is complex shapes. So we see here this part which has interior channels implemented, where these internal functions are only printable and only achievable by using additive manufacturing technologies. As well here, hollow structures, complex parts. So these designs were so not manufacturable by classical technologies. So even the cost per parts are here significantly higher than classical wise. They deliver new value to the customers of these parts and new significant benefits in terms of efficiency, and that's why it doesn't matter if the cost per part in direct comparison is higher. So looking in the automotive sector, I choose these two parts. So one example is from BMW. It's a first metal series component printed in placed in an i8 car from BMW, and it's reduced the weight around 40% of this component. So weight reduction is, of course, one key component in the mobility sector, where we can strategically plan into the future products. On the right side, we see the Bugatti bracket, which is an efficiency topic. So this bracket is promising significantly better performance in the bracket sector. So we see here the cost per part doesn't count anymore, because it's a performance increase of the function of these parts. Looking into the railway spare part sector, we see components from older trains which are not available anymore. So the aspect of design is not so important here, but the aspect of the supply chain, of the having the spare part on demand accessible is the aspect here. So the trains are sometimes waiting in the maintenance sector for several months to get the spare parts replacement. Now, using 3D printers, Deutsche Bahn claims they can significantly improve the maintenance within the sector. So this part is available within 1 week, and before it was a matter of 6 months. As well, they have customization applications, which are theoretically potential available for each serious customization application, where you write the name on a car or in the car or on a part which is customizable. So this kind of application as well. Let's look into consumer goods. Consumer goods is appearing since 3 years more and more bigger market. The glass frame market moves kind of directly to industrial grade 3D printing, as fantastic new designs are possible here. As well, a custom made fit of the glass frame is possible. So the softwares are in development here. As well, the shoe sector. So the shoe insoles, the shoe soles itself are here we benefit from 2 aspects. Customization, so exact fit to the foot or to the physical anatomy of the person, and as well new features like complex designs within the shoe sole help to generate higher performance. In the Shisu sector, so the skiers under us will understand where the benefit is actually here. We have an exact fit to the human body. That's why this is going to be definitely a significant benefit. And they are much more strategic relevant decision criteria why to step into additive. We just had a broad overview of the new value appearing through a printed product, but additive can be seen as well as a digitalization driver. If you implement a 3D printing process within your companies and highlight the first 3D printed parts as a lighthouse applications, it helps you to implement change processes within your company and drive your R&D departments into completely new directions and new customer and innovation-driven solutions. Therefore, we are offering as part selection methodologies where we screen your present part portfolio, do the assessment of your direction, which you actually as a company would like to move on. Is it either strategic decision criteria or really on a part level or a new significant value within the parts? And then we together identify the right focus and help, of course, with the approval, which TÜV major role is in the entire chain. Let's look at the risks. If we have an overview of the entire process, we see the 3D printing process in the middle is never an island. So it's always a combination of different pre and post processes. So analyzing the right part, designing the right features, positioning and nesting the parts for the process, printing itself, post-processing, and of course the quality assurance parts. So let me describe you the complexity a little bit on these three cases here. To find the suitable component and the suitable design, we need to understand what kind of minimum feature sizes are necessary for this part and printable. So the designer needs already at the first stage to learn how to design right for AEM. Designing for AEM, it's a crucial aspect for your designer, which is dedicated to implement products within 3D print and using 3D printing technologies. Looking further down the road, we need an engineer who is taking ownership of not only the design process but as well the CAM processes, where we position the parts for the process and optimize the positioning in that matter that it's economic, but as well approvable. So verifiable. We need a standard build setup, which we are able to trace and track. So reproducibility and traceability aspects. For example, in the printing process itself, why is that risky actually? The material property results from the printing process itself. Not like in conventional technologies, for example, CNC milling, we are milling out a fixed material property. Here, it's always generated new. And you can imagine if we have a platform where different part sizes are positioned in the nesting process here, we generate the risk that we generate always a new material property and slightly different to another part is in this early stage of the technology in terms of industrial use quite high. Therefore, this part is significant that we validate our processes, and there where TÜV can help as well. Post-processing, so validating the post-processes according to the product requirements. So it's blasting, CNC milling, coloring. There are several post processes which are always it has to be integrated into the entire process chain. And finally, the last step, the quality control. So looking at our portfolio and how we can help. So within the hard and software sector, we are taking care about the reproducibility of the systems. So solving here a huge existing pain points. So we are serving certification schemes to the industry which help to detect which system is reproducible for their applications. Feedstock and materials, so reproducibility of materials and processes, and of course the final approval is here our mission in terms of services on the market. Secondly, companies and their facilities. So the entire team and the production line needs to be aligned according to the state-of-the-art standards within the industry. And here we have a certification scheme where we help the company to implement a state-of-the-art production line with our assessment. And after this assessment, they were actually ready for being a producer within the industrial grade segment. We have trainings which enable the entire team, from the designer to the product manager and the engineer, to be ready for such a certification and be ready to implement change processes within your company. We work on next-gen AM solutions, so digital part certifications, which I'll explain later a little bit deeper, and of course the standardization. So the next standard what we are bringing out here is the DIN Spec 70071. This standard can be used by each manufacturing site to set up a production line, to set up their processes, the team, and it's going to be for free, and it's available in the market within the next 2 months. And of course, we are auditing that already and bringing this standard as well on the ISO ASTM level within the Joint Group 75. So it's going to be not just the German standard, but as well an international standard for production lines. So who are the players? Because it's not a task for just TÜV. We need to work together. That's what I would like to address here as well. So all machine manufacturers, material suppliers, the users, the service providers, the printing bureaus, the OEMs, which are implementing and planning products, the designers, and marketplaces, software and other software solutions need to work together to achieve an industrial grade level. And we are starting to address the standards to the market, which is the first one is the hardware standard. So, and this is going to be ISO ASTM standard. So every machine manufacturer is welcome to contact us and gets qualified by this international standard already today, because we are in the implementation phase of it. Each user, each OEM or service provider can then ask the machine manufacturer to qualify the system according to the industrial grade conformity standard, which is a wonderful scenario, because finally we have a reliable differentiation between those systems which are not usable for industrial manufacturing and those which exactly are made for industrial manufacturing. So here we offer technical reports for the dedicated systems, of course the certification according to our standards, and we are open for participation of others which would like to write the standards together with us. At the moment, we are focusing on powder bed fusion technologies, binder jetting technologies, MAX technologies, to to get the standards according the requirements of these technologies. But our aim is to implement all technologies which are which has a purpose to be used in industrial context. Materials. So who are the players in the material segment? So material suppliers, for example, for powder or fluids or filaments, they are able right now with our newest standards to set the difference between material which is ready for industrial grade manufacturing and these materials which are not for industrial grade manufacturing. So here we are offering several services. It's a metal powder supplier certification, where we certified the first metal powder supplier, which is a company from Germany, Rosbach. We are offering material validation. So if you want to validate your material properties for reproducibility and other aspects, of course, this can be done with us. And as well the feedstocks verification. We are thinking even further to qualify a material together with a process and printer for a dedicated use, which will help to reference a fixed material property. Because material property results always in combination with a dedicated end-use printer and process. So, who we have for producing? So the production partners are the service bureaus and sometimes as well OEMs if they have their own production lines. So looking here at the production sites, our vision is to enable a global manufacturing network of certified production centers. It doesn't matter for us, it's a service provider or an OEM who provides printing services. We are connecting with our industrial conformity standards for production sites. All centers which are fulfilling the today's standards. And here we wrote the DIN Spec 17071, which is a German standard, and the ISO ASTM standard is coming soon, which mainly focuses on quality assurance steps within the production line. So from the data preparation to system-related pre-processing, processing, and post-processing, we are detecting within 3 days at the company 250 criteria are set and helping the team to implement state-of-the-art solutions. It's already kind of a success story because we certified already 5 companies, which is Siemens, Toolcraft, Evonik, Protic, and Blue Production. And these companies are in Germany. And we have few external leads already. 5 companies from external are in the process. So such a certification, it doesn't happen overnight. It's a process and generally something between 3 and 6 months because the requirements are quite high. And the achievement of these requirements usually contains a lot of homework for the implementers. But a huge benefit that these teams here, or Protic or Siemens and Toolcraft, they are highly committed to high-end manufacturing and know what they are doing if they are taking an industrial grade order. As their processes internally are all reproducible and traceable, it helps as well the OEMs to plan their the outsourcing of manufacturing capabilities. So we strongly recommend the certified companies for all OEMs to be used as a partner of choice for their parts. What our customers are saying about the service. So what definitely is fact that we minimize the implementation time towards certification. So if you implement such a certification within your development, you usually don't need 2 years to set up your production to a basic level. with our certification scheme, you are theoretically ready within half a year. So it's dramatically minimize the time to production, to set up in production, and as well the costs, because trying and failing generates huge costs. And through our dedicated additive manufacturing specific certification scheme, we minimize those costs to maximum, because the people after our assessment know exactly what needs to be done and where to establish a reproducible and traceable production line. So how do we position this standard, the DIN Spec 7171 and Additive Manufacturer Production Site Certification? It's kind of based on top of management certifications like ISO 9001 and 9100, where just the general management system is audited. We are going on the process level with our certification scheme and auditing the competence on the manufacturing and shop floor, but as well the competence on the direct customer contact. So design questions, order taking in questions, how do you plan the entire industrial grade order is audited here. And this helps everybody in the market to have here a certified partner of trust, which is capable to take industrial grade orders. Another benefit of it is that based on top, we are able to offer product approvals, because these 80% here with the Additive Manufacturing Production Site Certification are already a great fundament to approve products within regulated industries. Whatever, if you print for medical, aerospace, airplane industry, pressure equipment, even consumer goods and scalable series production are benefiting from these standards. So, marketplaces. Many startups are appearing within the last few years here in this segment and offering marketplaces to the market, where they link the supplier and the purchaser together with such a marketplace. And what can we offer here? So we are offering a sealed cloud by TÜV SÜD, where the data which are provided from the supplier to the from the purchaser to the supplier are sent in the sealed cloud, and therefore we are assuring that IP rights, data safety and security, and cybersecurity aspects are covered. Therefore, we are linking our supplier network, our certified suppliers, within this sealed cloud. So in future, all orders which are related to regulated industries can be sent over this sealed cloud. Our vision is to enable digital part certification, and this is kind of the final vision for the next years. So we are drafting this already today with dedicated partners, where we show for specific systems and facilities which are certified for our certification schemes that a part can be certified on demand. Unfortunately, the certification is far away because there are so many gaps to be clarified. But what we can do today is already a part report on demand. So that's what we are working on, and it's going to be shown at the next Formnext exhibition in Frankfurt and in Singapore at the ITEP. And our global team is working here to this goal to really enable the industry through this on-demand part reporting to kind of enable faster implementation within regulated sectors. And the on-demand printing becomes with this kind of trustful. At the moment, as a concept study, let's see how we move then forward from there. but the solution looks promising. So let's finalize a little bit the implementation status. Firstly, for those which didn't step into additive manufacturing right now, they need a business model. They need a business model containing the additive manufacturing value for their parts and their services. That's what we discussed at the beginning. Please analyze yourself if you have a business model which utilize the potential of additive manufacturing. If not, please join our trainings. We have AM use case qualification trainings. We have trainings for decision makers. It helps to identify your business model of the future using additive manufacturing. You need to set up a dedicated innovation managers within your companies. Usually the implementation status shows that if you don't have innovative persons on board which are looking into the future of your business models, the future of your market, things are not happening. So you need an entrepreneur, a driver of these technologies within your company, and it's not a single person, it's a team actually. So you need an implementing team which finds the first application and implement those and shows the first lighthouse projects that the things are getting a momentum in your company. With that, you develop your strategy based on this first experiences within your company, or you will kind of get a feeling for your future strategy and how to reach the goals faster. So knowing of today is that TÜV can significantly reduce the time to implementation through our certification schemes and through our training schemes. You are welcome to implement our services into your strategy, how to enable additive manufacturing production within your companies for the next years. You need to think in terms of change. So we need to implement change processes. And change processes are plannable. So starting with the identification team, following then by the first success studies and successful cases, and as well opening then separated branches which are taking care about additive manufacturing. So this change management workshop strongly recommended for those which has already a business model, and then they can get into our Additive SÜD Academy and learn how to implement change management for additive manufacturing. Generally, the entire engineering needs to be educated with the new schemes. So starting with the designer, which needs to learn design for AM, following by the project engineer, which needs to learn the crucial quality assurance aspect, but as well the technology specifics. So this needs to be planned. It's not a task which is unplannable. So if you summarize in total, you could actually take these 6 crucial fields and analyze where you are. Do you have a business model? Do you have an innovation management, a strategy? Then you can plan your change management and hire the right staff or educate the right staff. And we have a training for that. So we train your designers, we train your manufacturing team, the quality managers, the persons which are in charge of to get the approval by a notified body like TÜV is as well. How to manage the entry stage. So what are the right parts? How do I need to implement change management? And business model workshops. This is offered by our TÜV SÜD Academy, and we from Team Additive are strongly involved into the content. As well, we are offering today the Trust in AM app, which you can forward to your design engineers, which help them to detect what kind of effort is behind a part approval. So for those companies which has already a product in mind, which they would like to print and they have data for it, you can use this app, Trust an App. It's online available. And your engineer can get fast access to TÜV SÜD's expertise. We have globally 25,000 experts, nearly 25,000 experts, which are experts from several industries and products. And here we link, with this app, we link your designer with TÜV SÜD's approval expertise, and this helps him to faster to identify what kind of approvals are required for this dedicated part in industry. So finally, we have a global team with over 1,000 locations worldwide in around 50 countries, and the global approach is significantly important for the success of additive manufacturing. As we know, on-demand production, and this is one of our core missions, to enable this, we need a global setup of auditors and be able to audit hardware, materials, processes, and sites on the global level. So especially highly scalable applications like the consumer goods sector, printing shoes, soles on demand, so shoe inlets on demand. These business models will appear within the next few years. So imagine to print a shoe inlet globally in a city, in a shop, or close to a shop. This can be enabled by our global approach. So finalizing this session, we have certification schemes and educational programs to make your solutions industrial AM ready. You heard about the 8 themes where we are acting in, and we are open to your pilot applications and to your project, and I am open to all of your questions. Thank you.